So one thing we want to cover today is about interfaces, and we might take up some kind of interface, but that will still require one more topic to be covered. We'll see if we can introduce generics. Okay, so introduction to generics might get covered. And so, okay, some introduction, so you can initially get started with it. Okay, so two topics we may like to cover this time. Okay, fine. But let's see. You have any questions from what has been covered so far? Any from any of the topics? Okay, I think then we proceed. Okay, so last I think in the abstract classes we have looked at an example where we had a class hierarchy, right? Let me show that, scroll up and show you the class hierarchy. So we use this class hierarchy where we have a class called vehicle, right? And a class called car as a subclass of vehicle. Then we had a class Maruti car, which was a further subclass of car, and Maruti car again has a subclass called Maruti Zen. Okay, out of all this, in this entire class hierarchy, we know in real world, okay, objects are created only of the Maruti Zen. Okay, and therefore all other previous classes in this hierarchy, they all have been marked to be abstract. Right? No one creates just a car. It would be a different kinds of car, right? There are so many different kinds of cars, and then we'll say, okay, among the one of those cars here we have taken as an example is a Maruti car, right? And within the Maruti car itself, again you can see there can be different kind of models. For each kind of a model, right? What is created is the car object which is created is of some particular model of Maruti car. Okay, so we have a class for that model also. Right? So for each model, okay, so the specifications for that model is in the class called Maruti Zen. Okay, Maruti Zen is a specific model, and the entire specification for that would be in the class called Maruti Zen, and therefore that is the one which is not abstract because we create objects of this. Okay, and we don't create objects of the superclasses of Maruti Zen. Okay, therefore we have just put them all as abstract. Okay. So the reason why we make something abstract, or we don't want, we would like that there has to be some subclass of this whose object would then be able to be created. Okay. And so this was done last time. So in this class hierarchy, under the class vehicle, last time we again tried to introduce another hierarchy, and we said, okay, let's have something like this. We would, under the class vehicle, maybe we have a class called aeroplane. Okay, when we're not looking into it, whether it will be abstract or not, that's a different thing altogether. But we have this aeroplane. Aeroplane is a vehicle, right? Is a relation. We are looking at is a relation, right? Which is used for inheritance. And aeroplane is a flying object. Okay, there are two things, right? Aeroplane is not just a vehicle, it is also a flying object, right? And there are many other things which are flying object, and they may not be vehicle, right? Other things which are flying object, oh, birds. Oh, we have birds which are flying object, right? We have, someone can say, okay, we even have a kite. Kite is a flying object. So if I say flying object, there are a number of things which, okay, there are a number of things which are under the flying object. So yeah, so putting currently with the dotted this thing. So you would have, you would have maybe a class called toys, maybe, and among the toys there is a class, a subclass of toy called kite. Okay, fine. So you may have class hierarchy, that's fine, but there is a class called kite, which is a flying object. Oh, sorry. I shouldn't be putting toys directly here. It's a small mistake. Yeah. Undo this. Okay. Okay, something like this exists. Like we have vehicle and aeroplane, or we have something called a class called toys. Okay, and that has a subclass called kite. Okay, and that is also a flying object. The idea is this, right? There are multiple things which are flying object. Okay, there'll be something like birds, and then again that's also a flying object. The idea is that this is flying object which is maybe a direct super type for multiple things, okay, which is anyway possible for any class also. For example, vehicle also is multiple subclasses, and that's fine. But something like an aeroplane, if I look at an aeroplane, what is an aeroplane? Oh, aeroplane is a vehicle and aeroplane is a flying object. Okay, multiple super types, right? So when we have multiple super types, when I'm using the word type here would be, could be class or those, any of those five things: class, interface, enum, annotation, or a record, right? Okay, and so we're keeping this more general here, right? So we have aeroplane as a having two direct super types. Okay, so what we have here is, as far as Java is concerned, in Java, a class cannot be inheriting directly from two superclasses. Okay, two immediate superclass cannot exist. Okay, fine. So what we have here is, we have the concept of interface. So flying object, it can be there, but it can be a, so if this is also fine, if this is an interface, okay, then this would be possible. Okay, so flying object here can be a interface. Okay, so let's see the distinction. First, what we'll do is, let's see the distinction between a class and an interface. Okay, now as far as the definition of interface is concerned, okay, in Java, the definition of interface has gone through certain changes. Okay, fine. So it prior to Java 8, what was the definition of interface is different from what it is currently there. Okay, so what we'll do is, initially let's try to look at the definition of interface which was prior to Java 8. Okay, and then we'll see what changes have come for Java 8 and maybe some reasons why these changes have come. Okay, okay, fine. So okay, so the definition of what's the difference between uh, a class and an interface? Okay, someone may even ask, it used to be a very standard interview question also, like what's the difference between an abstract class and an interface? Okay, so one thing about interface, like the abstract class, interfaces, uh, objects of interfaces are never created. A subtype of an interface, the object of a concrete subtype of an interface, that is, interfaces are always abstract. Okay, when interfaces are always abstract. So you may or may not declare an interface to be abstract, it is still going to be abstract. So even if you don't declare abstract, okay, it is abstract. Okay. So we have something like this. And for example, if we think about flying object as an interface, okay, it will say interface. So even if you're saying interface, maybe it's a public or not, that's a different matter altogether. Interface. And if I say flying object, I think I'll write it. I'll key it in. That's a better thing. Okay. Okay. So fine. Let's look at the difference between abstract class and interface. So one class and interface, the main difference. If I have to define an interface, right, maybe it's a public interface you may be defining. So let's say it's a public interface. So public interface flying object. Okay. So if someone just declares like this, right, maybe we're not looking at what's the body of this, but this is equivalent of, okay, public and abstract. Right? So you may not declare abstract, but it would still be considered as abstract because it's an interface. Okay, you don't have to necessarily. Okay. So prior to Java 8, what would go? So one thing is clear, because it's an abstract type, abstract method would be allowed in any interface. So is the case with the abstract class. Okay. So as far as so abstract methods. Okay, so similar to an abstract class, interfaces also have abstract methods. Okay, fine. So prior to Java 8, let's see what kind of members can go in an interface. Okay, so we're looking at that. So yeah, so if there is an interface, right? So how do we define an interface? I'll just put the syntax part now. So I'll put it this way. You have optional thing, which is modifiers. Okay, right. One of those optional modifiers is the abstract. It is abstract is nothing but a modifier which is optional and is always there. You may or may not write, it would be considered to be abstract. Then the keyword interface was used. Okay, you have the interface name. Okay, now as a super type, whenever we define something, right? When we were defining class, we were always giving the super class name, right? A super type rather. So similarly, in case of interface, here you can specify. So syntax point of view, it is optional, like we were using extends in case of a class. Here also we use the keyword extends. Okay, so we have extends and a list of, so it's a comma separated list of interfaces. It's not a class. You don't specify super type for an interface as a class. So class cannot be a super type for an interface. Okay? There's only one exception to this when I'm saying a class cannot be a super type for an interface. That exception is the class called object. Okay, fine. Only one exception to the rule is okay, so object class is anyway the super type for all the references. So from that point of view, yes. So if you are defining interfaces, you cannot specify a super interface, right? So this is the body of the, so I can think here that yes, this is the body of a interface. Okay, so in this there will be a body of the interface. So within the body of an interface, I'll just make a copy of this again. Okay, and let's see what can go inside the body of an interface. So within the body of an interface, you could have two kinds of entries earlier. So this is prior to Java 8. Okay, fine. It could be a variable entry. And you can declare a variable, right? Or you could declare a method. Okay. Now, what is the variable declaration? It was always, so whether you mention or not, right? It would always be public, static, and final. That means it's a constant. And you don't put a static block in an interface, okay? But you would have, so when we are writing a final, we know we need to initialize it, okay? So in an interface, if you are writing a variable declaration example, as an example, we can see the example, it would be, I can just say, okay, so, okay, let's say min height equal to, so minimum height for something to become a flying object, I want to declare that, and maybe it is 100 or something. Okay, so in meters you can say max min height in meters. So this is what you may declare, right? So when you declare like this, okay, it is equivalent of saying public static final. Oh, sorry, I didn't declare the type which was necessary. Sorry, maybe int equal, right? So the type was int, let's say. So this is equivalent of saying, okay, okay, so both are same. Okay, so you would have to initialize where you are declaring the variable. There's no, like, you won't be able to take the help of a static block to give the initialization to a final variable. Fine. So one type of member was variable declaration, right? Another member is a method declaration. See, one thing, what is the difference which has come out? When I said there's only one type of variable, which is public, static, and final. It's a static variable, right? You do not have instance variables. Okay, what this is, what has come out of all this is and so when you compare with the class, this is one big difference. Okay. And so interfaces do not have a interfaces will never have an instance variable. Interface, see, instance variable talks about object, right? It's related to the object. Static variables are not related to the object of the type. So let's see method declaration. So method declaration, okay. Okay, so in interfaces, so it would always be public and abstract, whether you declare or not. That is all, right? So only abstract methods were allowed in interface. Okay. Okay. And so example, in case of a flying object, if you look at a flying object, maybe you would have a method which says, so return type may be void, name of the method can be fly, and semicolon. So you could write an entry like this. It's a method declaration. Because this is same as when you write like this, it would be considered equivalent of public and abstract. Okay, so this is one thing. Right. So prior to Java 8, this was the only thing which was two kinds of entries. A variable, it would mean, oh, your variable is a static constant, static and final. And if it's a method, it means you can't write a body for the method there prior to Java 8. Okay, it means it's a public and abstract. That means all the members of interface were always public. Okay, one thing, all members of an interface were always public. Okay. Fine. If you look at this flying object, okay. Okay, fine. Yeah, I think let's first understand what is a, with one example of flying object, fine. What is an interface again? Okay, let's just have a quick look at that. So let's try to understand what is a flying object and how it is different from the classes which we have seen so far. So what is a flying object? Yeah, in general we'll say, oh, anything that can fly is a flying object. So it is talking about a behavior. It's only about a behavior. That is, it would have, it is more related to having methods. Certain kind of operations need to be supported by this type. Okay, fine. So that's one thing. So it is more related to the behavior than to the state. Oh, what does it have? No, it doesn't hold any information, right? But it would have these. So we are not talking about what kind of information it must manage and how it manages, what data types it uses, nothing of that talk. So we are not talking anything about we are only talking about some behavior, some methods which should be available on the objects of this type. If there is an object of this type, yes, they would have this method. So, right, so no object of an interface is ever created. Okay, what is created will be object of a subtype. which may be a class. Okay, it could also be the enum. It could, so enum also have interfaces as super types. Okay. Okay, so yeah, so if you look at flying object, yes, does a flying object need something? Can we say flying object, any flying object will always have certain kind of a thing? Right? Someone may say, oh, all flying objects will have wings, right? And that's not necessary, right? There are flying objects which do not have wings also, right? Okay, another thing is, we cannot say how a flying object will fly. Each flying object has its own way, right? That's why the method is abstract. Yeah, the idea of this is nothing but certain kind of a behavior. Okay, fine. See, someone can say, as just a simple another example, you could say another interface. Example for an interface could be, maybe we'll say dancer. Yeah. So yeah, there are certain a dancer would be an interface if you are looking at it from a very general point of view. When we don't restrict ourselves to humans, right? So even a peacock can dance. How it is dancing is different, right? So it's more on behavior. Okay, so we are talking about a certain behavior. We are talking about maybe a single method or a set of methods. When we take flying object, we have a single method called fly. Right? When we take dancer, it's a single method called dance. You may have a case where you might expect more than one kind of methods also. Okay, so but you're not interested in giving that what we call as implementation, right? So we don't say how it will be done, but what are the methods which will be required. That is what is stated in an interface. So this is Java, prior to Java 8, this is what was the case. Okay, now from Java 8 onwards, a few changes were done, and why those changes were required, let's see that. There were many interfaces which were created. Okay, there are some interfaces which are related to the data structures. See, we have data structures, right? So when we talk of a type of a data structure, right, we can understand in general terms what kind of operations must be supported. Actual implementation, how it will be done, that we can say people can decide their own implementation. Someone can write a still better implementation, right? Maybe a particular implementation suits a particular kind of a scenario. If you have less number of elements to be managed in a particular kind of a data structure, maybe a particular different implementation is better off. Okay, fine. Then so that's the whole idea, that yes, you will have a type, which is the type. Interfaces are also types. So you can have variables of a type which is an interface type. Right? So declaring a variable is not creating object. We know that, right? In Java, it's not like if I say flying object FO, right? There's no object of flying object, right? A declaration. Right? When we declare variable, example, if I say flying object FO, okay, there's no variable, there's no object. Okay, there's no object. It's just a variable which can refer to anything which is a flying object, right? So you can have variables for the interface. Okay, fine. So declaring variables is fine because that was anyway not a object. We can't have objects of interface type. That's one thing we know. Okay. So this is not the object of a, but how will FO be used then? Okay. So one could say FO equals, what can I assign here? Which object can implementation class object? Yeah. So new aeroplane, right? Assuming aeroplane is not an abstract class. Maybe aeroplane is abstract, but then in that case, yes, you'll say new something like this. Okay, and something like this can be done. And the idea is clear. The object which is created is of a non-abstract type. Okay, fine. So this way, okay, the whole idea should be clear that yes, there will be, because that is also a flying object. For Boeing 737, directly or indirectly, under aeroplane there will be Boeing planes, and then we'll have, okay, Boeing 737, that's the one, right? So maybe there's a, right? So this is the object being created of a concrete class, and the type is still flying object. So with this FO, the restriction here is, in Boeing 737, there are so many methods available, but with FO, I'll only be able to use fly. Fine. See, what methods can be applied depends on the type. You want to use methods of Boeing 737, what should be done? Casting. Or maybe someone says, oh, I just want to, I know this is at least, I know this is going to be an aeroplane. Okay, fine. You can cast into aeroplane and use the methods of aeroplane. Okay. Any other method of aeroplane that can be used. Okay. And what happens if FO is not at runtime? If FO is not referring to aeroplane or any subtype of aeroplane, that would be a error at runtime. Cast exception. I think we understand that now, right? Okay. So interface as a type, they depict a set of functionality, right, and nothing to do with the instance variables. So that's a big difference. Okay. Okay. Now let me just give a small example of interface, but this may involve a little bit of generics here, okay, which we'll try to cover next. Okay. We have in the Java API interfaces. For common data structures. Okay. And one of, they are found in the java.util package, and one such interface is list. Okay, so there is an interface for list. I'll not mention the generic at this point. I'll try to avoid it. Okay, so list has this list interface. So from Java to, you have this interface. Okay, one feature about Java which we have to understand is Java has always tried to maintain backward compatibility. What do we mean by saying it has tried to maintain backward compatibility? What is the meaning of backward compatibility? Okay. So backward compatibility would mean, okay, any code Java should right? It should work without changes. Okay. So this is something which they try to maintain to as far an extent as possible. Okay. Now, because of this, if you look at what happens because of this, okay, from the interface point of view, right? So if we consider that list interface, which was defined in Java 2, right? Since interfaces were only allowed to have abstract methods, okay, someone who has written a class to implement. Oh, we haven't seen this syntax, sorry. I think I'm jumping a little faster here. I'll just come back to the syntax for class definition, because now we'll have to talk about class also, not only interface. Relation between class and interface. Yeah, let's look at that and then we'll continue with this. Okay. See, one thing we have already mentioned, that a class cannot be a super type for interface. Okay, but interfaces can become super type for a class. Okay, let me come back here and put a small diagram. I think that should explain. Okay, so syntax wise and relationship wise, when we define a interface, okay, so if I have an interface I, let me put only I. Okay, if there is an interface being defined, okay, it can have, it cannot have a super class, that's one thing, and but it can have any number of super interfaces. So interface can have super interfaces, okay, and it can be any number. Okay, I should have shown this also with a dotted line. Okay, so interfaces I'll show that with dotted lines. Okay, so interfaces, one interface, when you are defining an interface, you are free to mention extents and only interfaces may be mentioned. So you have multiple super type for an interface, which will again be interfaces only. Okay, but when we define a class, okay, so class with a solid line. So if you define a class can have, so while defining a class, you can show only one superclass. Okay, C for the class. So a class can have one superclass, but it could mention any number of super interfaces. Okay, so this is a super type. Okay, and there can be any number of super types. Okay. For a class, let's see the relation. Okay, how did we show the relation between interface and the super interface? The keyword used was extends. And we say interface extends and any number of interfaces will be mentioned, comma separated. Okay, but when we define a class, we'll say, oh, it extends only one class. So the keyword extends is used for specifying a superclass. Okay, whereas we use a keyword called implements to specify the super type for a class. interface is being super type for a class. Okay, which are the super interfaces for a given class is specified using implements keyword. Fine. The idea is clear. I think I'll just quickly mention the okay, so this. Okay, so we can see from the syntax here, okay, that if I look at a general syntax for a class definition now, okay, so what is you have modifiers. This is for a class now. What I'm writing is syntax for class. Okay, so you have modifiers, right? Anyway, it is optional. So optional modifiers, then the keyword class. Okay, we have the class name, and then the optional part is extends and superclass. Okay, this is one optional part. Another optional part for a class definition is the use of keyword implements and list of interfaces. So when you define a class, this is how you define. So depending on what you are inheriting, whether you are inheriting an abstract method or not, your modifiers will have to be appropriately specified. Okay, if there are abstract methods which are inherited or you have declared them, you will necessarily have to use the abstract modifier, and it is not such that if I have an abstract, it should have an abstract method. That's not a requirement. Okay. Okay, so syntax for a class is like this, right? Syntax for interface, I think that we have already covered, right? Earlier, here we have syntax for a interface. Okay, so we say a class implements a number of interfaces. Now let me continue with the earlier thing which we were looking at. Okay, so giving backward compatibility, that was one of the things which was required, right? So any code written for a previous version of Java should work without any changes in the new version of Java. Okay. So now just think of this interface. Now I'm looking at the interface for list. Okay. Fine. Okay, it has come up with a set of methods in Java 2. All those methods were abstract. Okay. So okay, now let me put a question. Can we add new abstract methods in list? Okay, in a newer version? And, okay. Okay, let me add one more thing in a newer version without breaking. See the reason, what was restricting the interfaces. So see this you can understand, right? So can we know the answer to this? Yes or no? So can we add new abstract methods in list in a newer version? So answer was no. The reason is, if there is an abstract method which was not there earlier, any class who has implemented this interface list, he could not have those methods in that implementation class. Right? I'm creating a non-abstract class which is implementing the list interface. So it would have overridden the abstract methods which were provided earlier version. Right? Now in the newer version, if he is adding a new method to the interface list, okay, it would not work because he has to make the change then. A new method has come, or that needs to be added. The implementation of that has to be added in the code. So we say backward compatibility is when we have no change in the code and it is still going to work on. Okay. So this was a problem for us that, okay. So no enhancement for the interfaces was possible. Okay. One thing is, all the time what has been kept in mind is backward compatibility. It's, if they enhance, then backward compatibility is lost. Okay. So to overcome this problem, what they said, okay, if we add a new method in the interface, we'll also tell you a default implementation for the method. Okay. So fine, as an example, in the list interface, need for a sort method okay, we always felt, oh, there should have been a sort method here, but it could not have been added. Okay. So what they did is, okay, so from Java 8 onwards, okay, okay. So what can I interface? What kind of members can an interface have? Okay. Okay. So from Java 8 onwards, default methods were allowed in an interface, as well as, okay, another member. Let me just mention it here. Okay. Okay. And so static methods have also been allowed from Java 8 onwards. Okay. So members of interface now. Okay. So if I look at members of an interface, yes, so from variables point of view, static constants only. From methods point of view, okay, by default, so you may or may not declare anything, then it is abstract. Okay, fine. We have also default methods. That is default as a modifier for a method in an interface. Okay, so you can say, okay, for example, in the list, what they would have done, So we had this public interface list. Okay, I'm not using that generics. I will avoid that. Okay, so there were other methods. Fine, we had all kinds of methods. For example, we had a public method which was abstract. Even if keyword abstract never used, it is abstract because it's a method in an interface. Okay, so it will say, okay, we have this method returning boolean. There's a method called add where some element can be added. I'm not trying to use the generic here, so I'm avoiding that. So we had methods like this, okay, where it was, you don't declare even abstract, it is still abstract. Okay, so in Java 8 what they also did, they said, okay, we have a public and default method, and the method name is sort, and here you write an implementation. Because it is declared as default, it is like a normal method in a class. In class, when we don't say abstract, it is a normal method where we have to provide a body for it. So this is what a default method in an interface is. Because by default here in Java, if I don't declare any modifier, okay, right, then it is considered as abstract. Okay, so other than the abstract, which is an optional modifier, the other two modifiers which have been allowed are default and other one is static. Okay, someone might write like this, oh sorry, I forgot about the return type for the sort. Sort had a return type of void. Okay, so someone can say, okay, I want to have a public static void main method. Okay, fine, this is fine with the interface. And you write the body implementation. So other than a default or abstract, fine, this is abstract. This is like the implementation, like a normal method in a class definition. Okay, normally you have it like this. So for anything which is a list type, I have a way of sort. The idea here is any implementation of anyone who has created an implementation of list, he may not have thought about a method of sort and would not have overridden it, but he is writing a non-abstract class. So if you have a non-abstract class, which is because it wouldn't have thought about a new method which would have come. So for any new method in the API, if it is being introduced, it would be introduced as a default. So in this default, yes, various things can be done. It may be used to just give an exception at runtime saying, oh, this needs to be implemented. But at least compilation, and because if this is something which was in the older version, okay, the list usage is according to the older version, then they would not in any case have been using the sort method anyway. Okay, so this method could even be used for throwing exception also. We'll see what is throwing exception at a later stage, but that is also possible. Okay, but yes, you can put a default implementation for new methods being added. Okay, so one can always override this method, right? Fine. So we have now got we talk about three things. There is a types, everything is a type. We have behavior, methods represent behavior. Okay, and third thing is a state. The instance variables, they represent state. Okay, so prior to Java 8, we had multiple inheritance of types. So we had multiple inheritance of type, fine, okay, fine. But not of behavior or state. Fine. So we have multiple inheritance of behavior also. Okay. It is already having multiple inheritance of type, behavior, not of state. And there's no multiple inheritance of state. Okay. Fine. I think we can have a look at some example related to use of interface, because we have so far only used classes. So I'll take an example from the API itself. Okay, but this would require some use of generic. So I think we'll have to okay, so I have not finished with the interface complete discussion. Okay, but we will switch to another topic here. Okay, right. So and then we'll try to cover up with the example of interface from the API. Okay, so fine. So let me introduce the next topic here. Let's look at generics. Okay, some introduction to generics we'll have. Okay. Let's try to understand the concept of generics. Okay. To understand the concept of generic, what I'm going to do is I'm going to show you some modification in the account class. Okay, some change in the account class. The only purpose for this change is to understand the concept of generics, and we would not practically be doing that change. It's only to understand the concept of generics. Okay, so we would not like to apply it in the account class. We keep the account class as it is, but let's go ahead and think about how generics, what this concept of generics is about. So let's say we are defining this class called account. So we have defined something like this already. I'll just pick up the parts of the account class. So we have a public class account. Okay, I'm not keeping it abstract either. Fine, let's not look into it. And public class account. Okay, yeah. And in the account class, what are the members? What are the variables it has? Yeah. What kind of variables it has? Account number. Okay. So we have a variable called account number. What will be the type for the account number? It's a bank account. What should be the type for the account number? We have currently said, oh, it should be of type long. Someone could argue and say, no, it should be of type string. Right? Someone says it should be string. Someone says, no, it should be a big integer. There is also a class called big integer. We may look at it later, but the idea here is this account class, the account number, no one wants to fix it. What should be the type? The user of the class, the one who uses the class account, decides the type for the account. So we would like to have it as a something which is specified by the user of the class. The one who is, this is someone who is defining the class account. And then once a class has been defined, you know, we are using that class, right? We have defined the class account and we have used it in the test account class. Okay, we have defined the class rectangle and used it in the test rectangle class. Or so it could be used in any other class as well, right? Okay, so someone is defining and creating a new type called account, and he says, I would like to give the flexibility of deciding the type for an account number. by the user of the class. So he says, okay, let me have AN for account number, and I will have a field called account number. What is AN? There's no class called AN. We say our class account has a type parameter. It is a parameter, but this parameter is not for a value, it is for the type. Okay, the type is not fixed, the type is AN. Okay, so the whole idea is, yes, the type is AN. Okay, not fixing the type. Okay, fine. Similarly, someone could say, okay, let's have the other field. Maybe you want to keep name as a string, so that can be okay. But anyway, this could also have been modifiable. But someone says, oh, what should be the balance field? Again, the question arises. Someone says, no, I would like to keep it double with decimal places. Or someone says, no, it should be a big decimal, or it should be a big integer. Okay, there are other classes like that. Or it could be a yeah, it could be long the way it is currently. Okay, so someone says, no, I would like to have B as a balance field, and he says, okay, in that case I have got multiple type parameters. There are two type parameters in this. So when I define a class, okay, immediately following the class name in angular bracket, I can specify a list of what we call as type parameters. Okay, and AN and B are type parameters here. Okay, and if you look at the whole idea, now you can say, if I have to write a constructor, or how will I write constructor for account? Okay, yeah, what does it require as parameter? Three things. What are the three things? Account number, name, and balance. The type for account number not fixed. That's okay. I can use the type parameter where I have to declare a data type. I can use a type parameter where I need a data type within the class definition. Okay, AN, account number, string name, and B for the balance type, or opening balance, right? We had opening balance, right? So you can see this is still, you can write that code, right? And says, yes, this dot account number, the type is same. Account number is of type AN, ACN is of type AN, I can make the assignment. There's no problem with this. This dot balance equals opening balance. See, the types match. There's no problem with this kind of an assignment. They are of the same type. Okay, fine. So constructor like this, someone says, I want that public method to call get account number. When we have the method get account number, we will say the return type will be AN. It's not only the methods will have a parameter of type which uses the type parameter, it can also be a return type. And this is quite simple, right? This one says return this dot account number. They're still fine. Okay, so getter methods can be there, constructor. So the idea here, what I'm trying to show here is your type parameter AN has been used as a return type for a method, it has also been used as a parameter to a method. Okay, an used as a parameter to a method. Even b also has been used as a parameter. You have the get balance method, return type is b. Okay, so maybe this is kind of I've just given a partial code for the class. Okay, if it is a generic class, yes, this class, yeah, one thing here, such a class which uses type parameters, we call them as generic classes. So we have concept of a generic class, and similarly, similar to a generic class, we also can have generic interfaces. Okay. So from definition, yes, what I'll put it here. Okay, there are three things which are allowed to be generic. Class, interface, and methods. Okay. Okay, so classes, interfaces, or method which declare type parameters are generic. In case of classes, in case of classes and interfaces, the list of type parameters, okay, immediately follow the whatever class or interface you are defining. So immediately following that, you will be giving the type parameter lists. Immediately following the account, we have given the list of type parameters. That's a class being defined. Okay. In case of methods, in case of generic method, list of type parameters. Okay, is just preceding the return type. Okay. Just before a return type, for example, yes, if I was having a generic method here, I am not writing a specific, just as a, so you would have said, okay, so you would, for example, yeah, you would like to see some t as some data type, so type parameter, maybe void and some method name, okay, and you may have a list of things, okay. So this method here is a generic method. It has only one type parameter called t. Okay. See, within this I can use t. Even in my parameter list here, I may use t here also as a data type. So t is usable as a data type here, t is usable as a data type here, t is even usable as a return type. I can say, oh, this method has a type parameter t, it returns t. Okay, this is also possible. So t as a, so this is a type parameter which is not fixed. When you invoke the method, the type parameter will be specified, or may not even explicitly be specified. It can implicitly be derived by the compiler. Okay. So maybe you don't even find someone saying, okay, he'll just say method name and call the method like a normal method. Okay. Right. So generic methods are going to be like this. Okay. Just preceding the return type. So here we write return type, and just before return type you should mention this. So following the modifiers but before the return type. When we write a method, we have modifiers, return type, method name, and parameter list. Okay, so just before the return type. So between the modifiers and the return type is your type parameter, list of type parameters. We call them as type parameters. Okay, they're not just a normal parameter, they are a type parameter. Okay, so generic classes, interfaces, and methods. Okay, fine. Okay, fine. Now coming to the interfaces. One of the interfaces which we have in the Java API, and there is an interface called comparable, or it is comparable of E, some element type. We have an interface comparable of E. Okay, it is in the java.lang package. So with java.lang.comparable, anyway, we don't need an import to use comparable. Okay, because it's in the java.lang. Okay, it's a comparable of E. Okay, and how it is used. See, we have the relational operators. Which are the relational operators we have? We have the relational operator called less than, greater than, and less than, equal to, greater than. So we can make comparisons, right, for numeric type. Okay. Not relation, it's a comparison of, right? So we have the comparison okay. It's available only for the numeric types. We know, and only numeric values can be compared for less than, greater than. Okay. Now, many times you have the need to sort names. You got names, they are strings, and you want to sort them. How do you sort? If you have to sort names, how will you sort them? Alphanumerically, alphabetically. Okay, fine. But that comparison of less than, greater than, is it available for string? See, what is necessary for sorting? Okay, if it's a numeric type, I can be using, right? I'll be using if a of I, suppose it's an array, if a of I is greater than a of I plus 1, okay, I need to exchange their positions. Okay, we do such things, right? Okay, fine. Then you would like to exchange their positions. I'm not writing the code for that, fine. But yeah, the important part is we make comparisons of numeric values where we have to sort, we have to make comparison. Important operation is the comparison. You may use less than, greater than, whatever. right? But comparison operation is necessary. Okay, so to have a comparison for numeric, for reference types, okay, and comparison for reference types. Okay, let's see that. Okay, so what is needed for comparison of reference types? For example, someone says, oh, I have got these two account objects, I have got multiple account objects, right? You got account objects, and someone says, put these account objects in order. How will you put them? How will you order the accounts? I have an account with account number like this. Okay, name is, okay, I'm just giving an example here, and some balance is there, that's fine. Okay, so another account with a value of this, and some amount is there. Okay, we may have some other one here. What's that? Maybe some balances there. So maybe we have these three account objects. Someone says, oh, put them in order. How will you order them? And someone says, just put them in order. What should be the order then? Which one would come first? Out of these three, which should be coming first, which should be second, if they have to be put in an order. Someone just says, put them in order. He's not saying anything else. Oh, you would normally think with this, right? This should come first. Okay, so in order to sort them, so let me put them in a sorted order below this. So the sorted order would look something like this. Okay, so that's how you will sort them. This is nothing but what we call as the natural ordering for the account. So naturally, accounts would be ordered by their account numbers. Okay, this we call as the natural ordering for account numbers. Now this I have asked for account objects. Let me ask a similar question for another kind of a class called color. So I have got some colors. There's a color called blue, there's a color called green, there's a color white, there's a color red, there's a color called orange, okay, and you may have yellow. Oh, there's so many colors, that's fine. Now tell me, someone says put them in order. What would you do? Can you put these colors in a sorted order? I want to sort them. Can we put them? Okay. I'll now put a statement here. Okay. Account has a natural ordering based on account numbers. Right? If anyone ever has a list of accounts and someone just says nothing else but just says put them in order, they will just go with the account number only. So it's a very natural thing. So our account class has a natural ordering. Okay. Color does not have a natural ordering. There's no natural ordering for color. Okay, fine. So one thing is clear, account has a natural ordering. So it implements comparable. Oh, what is comparable? It implements comparable of account. You'll see this. It's a comparable is a generic interface. Okay. Color does not have a natural ordering and should not implement comparable. Yeah. Okay. So where do we use comparable? If we find there is a natural ordering. If there's no natural ordering, don't think of comparable. Comparable is name of an interface. Okay. Let's see this interface called comparable. Okay, how does it look like? Okay, so it is something like this. It has been defined as it's part of the java.lang package. Okay, it has been defined like this. It's a public interface comparable of E. Okay, and it has abstract methods. Okay, it has, so this is prior right from the beginning. Comparable interface has been there right from Java 1.0. Okay, and it has this public and abstract method. So it is a public. I'm not using the word abstract because by default in an interface it is abstract. The method returns in name of the method is compare to and takes as parameter E, the other element, okay, with which you are comparing, the element with which it is to be compared. The idea here would be, oh, I have an account object AC1 and AC. Suppose I have two account objects AC1 and AC2. Okay, I'm not talking about how they have been initialized. Let's not write all that code. But AC1 is having some object reference. AC2 is having another object reference. They are not null. And someone says AC1 dot compare to AC2. Okay, this is the way it will be used. What's the type of this expression? This is a int type. Okay, so result of comparison can be something like this. Okay. The interpretation here, now we say, oh, this is our relational operator. We look at it as something like, this is our comparison operation, right? So how does it compare? Yeah. Oh, this is giving integer. It's not saying less than or greater than. Okay. What has been expected here, okay, is that if someone is implementing comparable, the meaning of that int value is interpreted like this. If result is less than 0, then AC1 is less than AC2 or comes prior to AC2. Okay. Prior to AC2 in the ordering. When we are looking at it from the ordering point of view. So we consider AC1 is less than AC2. Okay. So now you can understand what is it the other way around. What about if result is greater than 0? Then after. Okay, not prior to, but it is after AC2. Okay, in the ordering. Right? And what's the third possibility for result? Is equal to 0. Okay, let me use the double equal to here. Then AC1 okay, they would be considered as equivalent. Fine. So this is how the comparable interface is available to us, with this idea that yes, the implementation of compare to method will decide which is greater, which is less. So any class which has a natural ordering should implement comparable interface. And how it helps is, if someone can now write a sort method which is more generic, which is only talking about comparable. And they'll consider that the elements which you are giving to me for ordering, okay, to put them in sorted order, they have this comparable interface being implemented by them. Okay. For example, we do have a method, we have a class called arrays. So in the java.util package, we have a class called arrays, okay, and it has some method like this. It has this method. It is only having static method, so it has a public and static method, okay, which is a generic method. So for some type t, okay, sort method takes array of t as a parameter. Some array is given and then it can sort them. So there is a code for this. Okay, they have written the code here to sort any array. It says if you are giving me an array for some type t, right, and I can sort it. Okay, so it's not necessary that you are giving. This is a sort method which is not for a specific type. It's not for a specific reference type. One point which I have to make also, okay, one thing which I can, which I'm reminded here is that t here is for, when we say this generic type, that type parameter is only for reference type. It's never for the primitive types. Okay, it's not for the primitive type, only for the reference types. Okay. Okay, one more thing. Let me go back to that generic example again. Okay, let's go to that generic thing again. Okay, so we can assume this class account an comma b. Okay, if we assume this kind of a definition, okay, the one who is using the account class, let's see how he will be using account class. Okay, so he might say account. Now the account is a generic, so whenever you want to use account, you must specify the types required. It said those two are parameters, not fixed. So I'll say, okay, the account number, AN stands for the account number, type for the account number, and say, okay, account number will be of type long. We can't use the primitive here, okay, that's one thing. And for the balance, again, let me use of type long only. So you could write like this, or maybe someone says, instead of long here, let me make it as a string here. Okay, so I have AC1 equals new account, and our constructor says, okay, I can take a parameter which will be of type string now, because what is the parameter required for the first type parameter? an here is a string. I can pass a string. Oh, we had account number, name and balance, sorry. So yeah, sorry, this is account number of type string. Sorry, it's not about name. So this is account number. Someone uses string here. Okay, second parameter was a name, so it says name. I think I'll put it in the next line. Okay, so someone puts a name, and then someone says, okay, oh, the next thing which is required is of type long. Now, because of the boxing conversion, which is automatically available, we can just write a long value like this. Okay, so this is valid for the above account class definition. Okay, so is similarly, someone could also have a, let's make a change here. In case of AC2, this is not a string, but this is a long. And maybe this is not long, but this is a double. And this is what is AC2. So AC2 equal to, now this would give an error. If someone tries to use this code, it will be an error. It will say, oh, here I'm expecting a long value. So if you remove this, this is valid. Okay, this anyway is valid, but if someone wants, he could have written something like this. Okay, it's a double type. I can use double. Okay, now look at the whole difference now. We have the method, so AC1 dot get account number. What's the type? What's the type for AC1 dot get account number? And what's the type for AC2 dot get account number? Is it the same type? What's the type for this? Type is string. What's the type here? The type is long. Fine, clear? Okay, fine. That's the return type. For return type was in terms of, so see this, what we have used here as a type parameter is bound with AC1 for whatever AC1 variable is, right? That AC1 variable is of the type account of string comma long. We read it as account of string comma long. Of, we use the word of when we have those type parameters. Okay, so you're now giving, here you are giving the actual, we say this is invocation. We are the users of the account class. Earlier what we had was a definition of the account class where it used the type parameter. That is the type parameter, and these are the types which have been used here. Actual type. Okay, this is the use of actual type has been specified here. Okay, this is the actual type, and this is your value according to the actual type. Okay, so get account number, same way. If someone was saying, what is it? We have this method called, suppose I think of them adding a method here. See, in constructor we have seen, but someone could even have added a method, right? What would be the method? Public method returns void. Name of the method is deposit. What should be the parameter to this? Whatever is the type for the balance, same will be the type for my amount also. Okay, okay. I'm not currently writing the code here because we have a problem with this. Okay, we have some kind of a problem with this. I'll explain the problem here now. Okay, okay. So now think of balance. Balance, someone invokes this, right? So balance can be any type. Okay, my question here, I'm writing some method here. So there is a method being used here. Okay, this is a non-static method. That means balance field is going to be available. So if someone says this dot balance, okay, what methods can I invoke on balance? What are the methods available to me for invocation on the balance field? I am defining the class. Type is not yet known to me. Type is not known. It is a parameter. What is the type for balance? B. There's no class or anything called B. What's a list of methods which I can use on balance? Only object class methods? Yes. Only methods of object class only. Because it is, everything is object for us. So these methods are what you can easily use. Okay, fine. Now let me show you a class hierarchy. I think I have mentioned this class hierarchy earlier. I'm not sure if I've done it or not. Oh, sorry, I didn't do it probably. Yeah, but we have a class. Okay, I'll have to put the class hierarchy. I'll just put it before this. There is a class called number, which is an abstract class. Number is a abstract class. It has subclasses. I'm writing in this manner. There are some subclasses. You recollect those wrapper classes? Byte. We have the class called short. We have the class called integer. We have the class called long. We have the class called float. We have the class called double. Okay. These 6 classes are subclasses of number. Over and above this, there are other subclasses of number. Okay. The other subclasses of number, I was mentioning big integer. There's something called big decimal. Okay. And there are a few more. Okay. I'm not mentioning them here currently. I think there is something called atomic int. I think it is atomic int. Atomic int. These are from different packages. For example, this is from the Java. This is from Java.math package. These two are like that. Okay. And this one is from java.util.concurrent package. There's atomic int, atomic long, similar thing is there, right? So this is Java util concurrent package where we have such classes. But the important point is they are subclasses of number. Okay. Okay. Now let me make another statement here regards to the wrapper classes. These we know are the wrapper classes. Plus there are other wrapper classes. The character class, the Boolean class, those two are left out here. Those two are also wrapper classes. One statement I need to make regarding all the wrapper classes is okay. So all wrapper classes are implementing the comparable interface. Right? So for example, we have the class, okay, we have the public class called, let me give just one example, integer, and it says it implements comparable of integer. Okay, and there will be an implementation. Yeah. So there is this entire body of the integer class. I'm not writing the body of the integer class, the entire body, and that goes here. Okay. Now, since it says it implements comparable of integer, right? Fine. Because of comparable, which method will be needed? It needs to implement the compare to method. It is comparable, has a natural ordering. If you have a natural ordering, you will have to provide a method called compare to, which takes as parameter. What should be the parameter? Okay, let me show the comparable interface, which we had written somewhere below, I think, right? Where is the comparable interface? I think I have written somewhere down. Yeah, this is the method which it has. The compare to method says if it is comparable of E, the parameter should be of type E. Okay. So from this point of view, can we now write what is the comparable for the integer class? It says comparable of integer. So what's the method compared to having? What's the parameter here? And we have said comparable of integer, right? And so the parameter is a integer. Okay. Fine. So that's the other value with which you are comparing the current integer value. And yeah, this would have its, I'm not writing the implementation yet, but there's support for this. Okay. So that can make the comparison and return a negative, positive, or a 0. Negative means the current object is less than the given value. Okay. Or the current integer value is greater than or less than. Accordingly, we have the integer being written by the comparator. So this is there for all the wrapper classes. So it is byte, short, integer, long, float, double, character, boolean, everyone. For every wrapper class, we have this comparable interface having a method called compare. So fine. So this is comparable, which is available, right? So this is about comparable. Then we have the class account. Now coming to this type parameter, we have with the generic classes or interfaces. Okay. I'll rewrite it again. Okay, just to make the line shorter. I don't want all of this to be mentioned here. Okay. We have what we call as a bounded type. Our class account has two type parameters currently, an and b. We are bounding it by saying it extends number of, no, there's no of, it extends number. It extends number. Number is a superclass for byte, short, integer, long, float, double. Fine. Other classes like big integer, big decimal, atomic int, atomic long. Okay. So number class has all of them as subclasses. Okay. Now look at the usage. Fine. So keeping this in mind. Now, if this is what the case is, okay, let me show another, let's have other two declarations further. Okay, now with the new definition, okay, with the old definition, let me just put it like this. With the old definition, okay, just continuing with the old definition where we did not put extends. It would also have been possible for someone to say string comma string, there's no restriction. This is AC3. And then he would be passing a string as a parameter here. Or someone says, I want to have the balance to be of type rectangle. There's no restriction. And this could have been R1, where R1 is some object of rectangle which is already created. This is what is the coding which would have been allowed, right? Can we allow balance to be a string type? If we are saying type parameters, right, they will have to have some actual type, data types to be specified for them. Okay, fine. With the earlier definition, this was possible, but when I have used, once I have used, what is it that I changed? Fine. What is the change we have done? For the type parameter b, since I have put a bound, okay, so that should give us a compilation. Okay, so you are saying no, though I have given you that you can use it as any data type, here I have a bound. It must be a number. It must be a number type. Anything which is a number or any subtype of number. That's what we meant when we said, okay. So what we had done was we had said public class account of, it said an comma b extends number. So we have given a bounded type parameter. B becomes a bounded type parameter. Then it's a bounded type parameter. Okay. Fine. Okay, I think we'll have to continue tomorrow. Okay. Fine. But we'll continue with the same topic tomorrow. It's not your role. Interfaces also, maybe I'll try to cover a little more on interface, but using the example of comparable. And because it involves generics, so some introduction to generics was also necessary. But we'll have to clear out so that and, it should become very clear to you. I think currently it may not be that clear. Okay, looks a bit complicated at this moment, but yes, we'll have to clarify that also. Okay, fine, we'll do that. Okay, so we continue tomorrow.